Hey everyone, welcome back to Edgeverse. Imagine this. You're drifting through the coldest, darkest void between stars. No sun, no light, no hope of a Goldilocks zone for billions of miles in any direction. And yet, deep under a frozen crust, an entire ocean of liquid water is teeming with life, powered only by the slow heartbeat of radioactive rocks. Sounds like science fiction, right? Wrong. It's science possibility. And some of the smartest astrobiologists on Earth now think places like this could be the most common homes for life in the entire universe. Today we're throwing the old habitable zone map in the trash and going way beyond Earth 2.0. We're talking rogue planets, nebula clouds, even black holes as potential cradles of alien life. Buckle up, this is a mind-bender that might completely change how you see the cosmos. Let's dive in. First things first. What even is the habitable zone, and why are we suddenly saying it's not enough? For 30 years, ever since we found the first exoplanets, astronomers have been obsessed with the Goldilocks zone, that magical ring around a star where it's not too hot, not too cold, but just right for liquid water on a planet's surface. Earth sits pretty in the middle of the sun's Goldilocks zone. Makes sense. Water equals life, right? Here's the problem. Out of the 6,000 plus exoplanets we've discovered by 2025, only about 2% are in that classic zone around their star. 2%. That's it. So either the universe is unbelievably stingy with life-friendly real estate, or we've been looking through the wrong lens this whole time. Spoiler, it's the second one. Earth's own biology has been screaming this at us for decades. We've found microbes living in boiling acid pools hotter than your coffee, bacteria happily swimming in Antarctic ice at minus 20 degrees Celsius, and entire ecosystems miles under our feet that have never seen sunlight in billions of years. These are extremophiles, and they're proving that life doesn't need a sunny beach and 25 degrees Celsius. It just needs three things. 1. A solvent. 2. An energy source. 3. Enough chemical complexity to get the party started. That's it. Everything else is negotiable. So let's throw away the old map and explore the new cosmic real estate market, starting with the wildest listing of all. Rogue planets. These are full-sized worlds that got kicked out of their star systems billions of years ago and now wander the interstellar void in permanent darkness. No star. Zero sunlight. Temperature? A balmy minus 270 degrees Celsius on the surface. Sounds dead, right? Think again. Earth itself pumps out 47 terawatts of heat from radioactive decay in its core. That's half the power we use as a civilization, coming from glowing rocks. A bigger rogue planet, say a super-Earth or even a mini-Neptune that kept a thick hydrogen blanket, could stay geothermally warm inside for trillions of years. Under a kilometers-thick ice crust, you could have a global subsurface ocean kept liquid by that internal heat, just like Jupiter's moon Europa, but with no star required. Life down there wouldn't photosynthesize. It would run on chemosynthesis, eating rocks and hot water, exactly like the ecosystems around our deep-sea vents. And here's the crazy part. These rogue planets might outnumber stars in the Milky Way by 100 to 1. 100 habitable worlds drifting in the dark for every sun with planets. Mind blown. But detecting them? Nightmare. They barely glow in infrared, and we've only directly imaged a handful. Future telescopes might catch their faint heat signature or spot them via gravitational microlensing, but for now they're ghosts. Ghosts that could be absolutely covered in alien oceans. Okay, let's go even weirder. You've seen those gorgeous glowing clouds where stars are born. The Orion Nebula, Eagle Nebula, all that. We used to think they were just pretty chemistry sets. Turns out they're packed with over 200 different organic molecules. Alcohol, sugars, even amino acids, floating around on dust grains at 10 degrees above absolute zero. Now, I'm not saying little green men are having parties in there, but some chemists and astrobiologists are asking, could self-replicating chemistry happen on the surface of those dust grains, powered by cosmic rays and radioactive decay, running a billion times slower than Earth life, but still evolving over millions of years? We're talking life that needs a planet with liquid water and a star. But the universe might have life that's basically a living interstellar dust bunny. It's speculative, sure, but the raw ingredients are definitely there, and the radiation shielding from all that dust is actually better than Earth's atmosphere for blocking deadly UV. Back to more familiar territory, but still way outside the old Goldilocks box. Take red dwarf stars, the most common stars in the galaxy, 75% of everything. Their habitable zones are so close that any planet there gets tidally locked. One side eternal blazing day, the other eternal frozen night. Old models said these worlds would cook on one side and freeze on the other, uninhabitable. New 3D climate models say nope. If the atmosphere is thick enough, it acts like a giant heat highway, pumping warmth from the day side all the way around to the night side. You end up with a ring of twilight where oceans stay liquid forever. Some scientists now think tidally locked planets around red dwarfs could be the most common habitable worlds in the galaxy, way more than Earth twins around sun-like stars. And don't forget subsurface oceans. Europa, Enceladus, maybe even Pluto, liquid water miles under ice, kept warm by tidal squeezing or radioactive decay. Scale that up. Any exoplanet or exomoon with enough internal heat can have a hidden ocean even if the surface is a frozen hellscape. From space it looks dead. Under the ice? Potentially another biosphere. I promised you the darkest corner, so here it is. Primordial black holes. Tiny black holes possibly formed in the Big Bang itself could still be floating around today. If one is soaking up even a little bit of interstellar gas, it forms an accretion disk that glows hotter than entire stars. That creates the most insane energy gradient in the universe, from billions of degrees near the hole to near zero far away. Life as we know it would be vaporized instantly, but life as we don't know it, maybe built on exotic silicon chemistry or magnetic plasma structures, could theoretically surf that gradient, living fast and dying young in ways our carbon brains can't even imagine. Isn't likely? Probably not. Is it impossible? Surprisingly, no. The laws of thermodynamics don't forbid it, so we keep it on the table. Here's the punch in the gut. If rogue planets, tidally locked worlds, subsurface oceans, and all these other places are potentially habitable, then the galaxy should be crawling with life. We're talking trillions of habitable environments in the Milky Way alone. So why haven't we found any biosignatures yet? Why no radio signals? No megastructures? No nothing. A few possibilities. Most life stays microbial and chemically quiet. No oxygen atmospheres to spot from afar. Abiogenesis is actually the hard step, even if habitable zones are everywhere. Intelligent life is rare and usually wipes itself out. Or we just haven't built the right telescopes yet. JWST is already sniffing exoplanet atmospheres and finding water, methane, maybe even weird disequilibrium chemistry. The upcoming Habitable Worlds Observatory in the 2040s will directly image dozens of Earth-sized worlds and read their atmospheres like books. We might be one telescope generation away from the biggest discovery in history. So here's the take-home message. The universe isn't a bunch of stars with a few rare Goldilocks planets sprinkled in. It's a cosmic ocean of possibility. Frozen rogue worlds with hidden seas, red dwarf planets glowing under perpetual sunset, ice-covered moons with underground oceans, maybe even living chemistry inside the nurseries of stars themselves. The places we once called the darkest corners might turn out to be the brightest beacons of life. We just built our first flashlight bright enough to start looking. If this blew your mind and you want more cosmic deep dives, smash that like button, drop a comment with the weirdest place you think life could hide, and subscribe with notifications on, because the next decade of exoplanet discoveries is going to be absolutely wild. Thanks for exploring the universe with me. Clear skies, and keep looking up, because the answer might not be around a sun-like star. It might be drifting alone in the dark, waiting for us to finally notice.